All right, so I'm going to start with the hypothalamus. The section on the midbrain tegmentum stuff isn't very big, and I didn't have anything super awesome for that anyway, so we're just going to start with the image on page 130 in the CNS textbook. Okay, so basically I just draw the whole thing out, and then we're going to go through and label it. Same kind of way I did it with the spinal tract mnemonic. Draw it out, we'll do a mnemonic, and then we'll work our way through. So I draw this like a giant fish. Here's a little fishy lips over here. I'm going to draw an eyeball right here. Right in the middle, in the superior aspect, that's where we're going to find our thalamus and our massa intermedia. On the back side, we have our pineal gland and our superior and inferior colliculus. Okay, so this mnemonic is about my friend Jeremiah. He was in the Marine Corps. In the Marine Corps or any branch of the military, in the mornings he'll do physical training typically, and they'll get up and it'll be, do 500 push-ups, 300 sit-ups, run 7 miles, puke, have breakfast, and then back to PT or something. Every now and then they'll let them do something different, like kickball or baseball or some other American pastime that isn't as boring as doing push-ups and sit-ups. So this mnemonic is a letter from Jeremiah to his superior officer saying, hey look, we're totally allowed to have these other activities if we ask for them. So it goes, pardon me, designated veterans are totally allowed particular American pastimes. Should someone call and plead. So the way that this works, pardon me, designated veterans are totally allowed particular American pastimes should someone call and plead. We're going to be working from posterior to anterior, superior to inferior, in basically 3 columns. I'll draw those columns now. Okay, so we're back here, then we're going down here. The first 2 are pardon me. So posterior nucleus and the mammillary body. I already screwed up. I do not just draw a P in a circle for posterior nucleus. This is the first thing I draw, so it gets the most amount of effort out of me. I'm going to draw a snowflake. Okay. I draw a snowflake because the posterior nucleus is the nucleus responsible for when your body gets cold. This is what regulates your internal temperature. So I draw a snowflake for when your body gets cold. There's a number of pairings in the hypothalamus. So there's a posterior nucleus and an anterior nucleus. There's something that warms you up and something that cools you off. There's a pair of gastrointestinal nuclei. There's a pair of parasympathetic nuclei. We'll get to all those eventually. So P was posterior nucleus. M is for mammillary bodies. If you remember from Harry the Frog prints, those were found right in his crown in the interpeduncular space. Mammillary body is responsible for short-term memory. If you don't remember what the mammillary body is for, it's because your mammillary bodies aren't working, because I just told you what the mammillary bodies were for. Short-term memory. Okay. Moving to the next part, designated veterans. So we're kind of in the medial area here. This is the dorsomedial nucleus. And this is the ventromedial nucleus. Okay, the dorsomedial nucleus, that's going to be gastrointestinal information and parasympathetic information. So I was talking about the pairings. Here's one that is one from each of the pairings. GI and parasympathetic. For ventromedial, on the ventral surface of your body in the middle, that's your stomach. Here's your other GI one. That's going to be your satiety center that determines when you're full. So designated veterans are totally right here above the pituitary gland. I'm going to draw this arch. That's for the arcuate nucleus. The arcuate nucleus contains releasing factors. Those releasing factors are released and tell the pituitary gland what to do. So basically, they'll send out a signal to tell the pituitary gland to release hormone X. Just inferior to that, on this surface right here, it's not a nucleus as much as it is a feature. It's called the tuber cinereum. There are a bunch of kind of tubular protrusions. And they're the projections of the arcuate fibers heading towards that pituitary gland. Is everyone good with those two columns? Are there any questions? All right. So pardon me, designated veterans are totally allowed. We're going to go right up to here. Okay. That's the anterior commissure. He will guaranteed have a question on your exam that says, basically asking you to compare your knowledge of the corpus callosum to your knowledge of the anterior commissure. The corpus callosum, that's the huge networking center of the brain, like 300,000 fibers that cross from one lobe to the other. The anterior commissure, that's like 30,000 fibers. He asks it every trimester, you know, which of these features will have 30,000 commissure fibers in the brain. You'll see commissure from anterior commissure, and it won't be that one, it'll be corpus callosum. But this is the one that has fewer. Are totally allowed. So this kind of jumps around a little bit, and it just happens to be how the nuclei are drawn out in the text. Particular American pastimes should someone call and plead. I just did it all out. So it's particular American pastimes should someone call and plead. Just going to jump to the last three because they're not so much nucleuses as they are locations. This is the optic chiasm, where those optic fibers decussate. And this is just the anterior and posterior pituitary gland, the adenohypophysis and the neurohypophysis. When I'm drawing the nuclei for these next 5 in here, I draw them kind of specifically. The first one gets a triangle, and then I skip and I do a moon shape. This one gets a triangle because the V in the triangle cues to me that that's the paraventricular nucleus. And then the other oddly shaped one, I draw it like the Lucky Charms moon because it makes me think of a Frank Sinatra song, When the Moon Hits Your Eye. What's better than a moon is a supermoon. So that's shaped like a moon, supermoon, super eye. This is the supraoptic nuclei. And they both have unique shapes because, again, we're talking about a pairing. These two nuclei together initiate the release of antidiuretic hormone and oxytocin. Can't spell. I will never forget what oxytocin does as a hormone. In my hometown, there's CVS, which is kind of like a Walgreens, and there was a number of robberies over the years at the CVS. They would go in and steal Oxycontin. This one time, a couple of not as intelligent robbers robbed oxytocin. Oxytocin is a labor inducer and stimulates milk letdown. So I always imagine those two robbers, like they got their pills, they're back at their whatever pad, they're popping them, and they're getting severe abdominal cramps, and they're lactating. So it's kind of a funny image for me. That's what these two nuclei do, is oxytocin and ADH. Between these two nuclei, we have this A here. Where there's posterior nucleus, we're also going to have an anterior nucleus. All he says about this is that that does parasympathetic information. So that's that other pairing there. And I'll tell you, after CNS, I've never heard about the anterior nucleus of the hypothalamus again. So a lot of these other ones you'll hear about again in physiology 2 or 3, but I've never heard of the anterior nucleus again. So this eyeball, we haven't really talked about that at all. If I'm going from this direction like I was for the mnemonic, I'm going to get to this before I get to this eyeball. That's the preoptic nucleus. I always draw that as like a flame because this is the other pairing I talked about. As your body cools down, the posterior nuclei engages to keep you warm. As your body warms up, the preoptic nuclei engages to keep you cool. So that'll be like one of the things that induces your sweat reflex. So the supraoptic nuclei is named for its relation to the optic nerve tract fibers. This one is above the chiasm. It's the suprachiasmatic nucleus. Suprachiasmatic, sorry. And this one is going to be involved in your 24 to 25 hour sleep cycle, your circadian rhythm. and it's going to be the light-sensitive part of your circadian rhythm. The reason I specify that, I'm going to take a different color marker here. The suprachiasmatic nucleus communicates with the pineal gland, which is the non-light sensitive part of your circadian rhythm cycle. Also, just for completion's sake, I've talked about a lot of pairs. I said if there's a posterior, there's an anterior. Here's an anterior commissure, and I didn't tell you where the posterior commissure was. If this little guy right here with the nose and the lips, if he was to have a mustache, that would be the posterior commissure. Are there any questions on any of that? Does everyone have everything that's on the board? I'm going to erase it. Okay, the next thing I'm going to do is the Broadman areas. If you've already seen the video, then this is going to be a review for sure. Basically, when I looked at the Broadman areas, I wanted a way to work through all of them in a nice, easy pattern. What was nice is that there were 12 sequential ones at the beginning, 1 through 12. A clock face also has 12 numbers, so I based it on a clock face. I guess you guys had a question on your Broadman area quiz about the frontal operculum. I never would have gotten that right. That was a tough question. Holy cow. What was the question exactly? Do you guys remember?
Which gyrus is the Broadman 44 located in?
Good job, Torgrid. Okay, so when you look at the brain, anterior, posterior, temporal lobe, frontal lobe, occipital lobe, parietal lobe, we're going to start with these numbers. What's nice is they have a nice flow pattern to them. So 1, 2, 3, 4, then jump over 5, 6, 7, 8, 9, 10, 11, and 12. That is the worst brain I've ever drawn in my life. Let's go with that. Okay, so the memory system for this is based on my teenage years. Call it middle school. So in middle school, I had to get up to get on the school bus. I had to get up around 5 o'clock in the morning because I lived far enough out into the sticks that it took an hour for my bus to get there. So I get up at 5 o'clock, but really I hit snooze 9 times like I still do today. So I really wasn't getting up until 5:39 or 5:40. And during that hitting the snooze button cycle, you get some pretty crazy dreams. Dreams that you would need expressive use of creative vocabulary to describe to anyone. So Broadman areas 3, 5, 39, and 40. And for your reference, 39 and 40 are going to be right in here. These areas right in here, that's going to be creative use of expressive language. Okay, so 5:40, I'm finally out of bed. 6 o'clock, I'm headed downstairs. I'm fully dressed, but I'm not very excited about it, so I'm kind of just shuffling like this. I'm not using any of my distal extremities to move. I'm walking like a zombie. Broadman area 6 is use of proximal extremities. So here we are, Broadman area 6, in that prefrontal section for control of proximal extremities. Okay, 7 o'clock, I'm on the school bus. I've got, like I said, an hour bus ride to school. What am I going to do for an hour? I'm going to tell all of my friends about these wild dreams. So 5, 7, 39, and 40. Again, creative use of expression language. So all of these are going to be incorporated in that. So I finally get to school at 8 o'clock. I'm in the classroom, and for the first half hour or so, I'm completely useless. I'm just sitting there. My eyes are going back and forth. Okay. I turn this 8 sideways so that it looks like eyeballs. Broadman area 8 is motor control for your eyes. Okay, right here. So finally 9 o'clock hits, and I'm actually engaged as a student. So from about 9 until noon, I'm thinking, I'm using abstract reasoning, I'm considering behavioral approaches to problem solving. That kind of thing that in essence makes us human, that's all going to be 9 through 12 here in your frontal cortex. So 12 o'clock, obviously lunchtime. Lunchtime becomes recess. Recess, you come back in. And from 1 to 3 o'clock, it's the afternoon. You're useless again. You don't feel like being in school anymore. Broadman areas 1 through 3, that's your somatosensory cortex. So right here, 1, 2, 3, all of this somatosensory. Finally, 3:30 rolls around, I'm out of school. 4 o'clock, I'm at soccer practice, okay? Or I'm at baton twirling, whatever. Things where I have to use my distal extremities, okay? I have to control them very finely to throw that baton up in the air. I didn't do baton twirling, but you can imagine if I did, I'd have to have finger dexterity. So Broadman area 4, right here, we're talking about distal extremity control, relative to Broadman area 6, which was proximal extremity control. So soccer practice is over, it's 5 o'clock. I'm going to switch to military time. So 1700 hours is 5 o'clock in military time. In the military, you do target shooting, so I draw a bullseye on the back. 17, 18, and 19. So for dinner time, I go home, I sit on the couch, and I'm watching television while I eat. So this whole 17, 18, 19, that's your primary visual cortex. Couldn't think of the word visual. Primary visual cortex. That's all going to be contained inside your occipital lobe. So we've covered the parietal section largely. We've covered the frontal section and the occipital lobe. We're going to move to the temporal lobe. The temporal lobe, we start right here. Broadman area 22. Ooh, that's a 20. 22. Just above that, Broadman area 42. 41, 42. So I'm watching television on the couch at dinner time. When I was in middle school, the Dallas Cowboys were excellent at football. Troy Aikman, Emmitt Smith. Emmitt Smith was number 22. He was an excellent running back. In order to be a good running back, you need good cleats. His were Nikes. So Emmitt Smith wore Nikes, Wernicke's. That's the name of this area. And they didn't have like mic'd up in the NFL back then. If you were at a football game, the most you'd ever hear out of a football player was a grunt if he got slammed or something like that. Wernicke's area is speech utterances, like the beginning part of a word. If I can't think of the right word and I'm like, that's Wernicke's, okay? The other thing that Wernicke's responsible for is hearing memory. So I'm thinking back to when I was in middle school, watching football, and I can hear the football players grunting. That's a hearing memory. So we're talking about speech utterances and hearing memory. That is different than 41 and 42, which that's your primary auditory cortex. Okay, so I'm just going to go sequentially right now. So we went 41, 42. 43 is going to be right here. And 44 is going to be right here. So 43 is kind of in that sensory area, right? 43 is going to be sensory to the mouth. So we're talking about taste. 43 is a Broadman area associated with taste. The way I remember 44 actually came as a suggestion from one of my friends. Does anyone know who our 44th president is? Barack Obama. Okay, embarrassing if you didn't know that. So 44th president, Barack Obama. This is Broca's area, okay? Barack, Broca, kind of comparable. What does Barack Obama love to do? He loves to talk, right? This is going to be motor to your mouth for speech sounds. And I assume that makes sense. We have 43 found here kind of close to the somatosensory cortex. 44 is closer to the motor cortex. Motor for the mouth, sensory for the mouth. Okay, the last part is a fart joke, and it's unfortunately at the benefit of my mother. So my mother's birthday is an easy birthday to remember. It just happened. It's February 3rd, 1948, so 2348. 2348. I do it that way because then I can get 34 and 28 out of it. I have a peanut butter and jelly obsession. It's not necessarily a good thing because if I eat too many of them, I tend to fart a lot more. My wife is very upset about this as well. But my mother, when she farts, it's truly like, oh my God, what just happened? 34 and 28, those are smell. My mother will never see this video, and if you try to share it with her on Facebook, it will not be pretty. So those are the Broadman areas he focuses on. He typically doesn't do a lot with right hemisphere, left hemisphere. I think he might have one question on that, but he doesn't stress it too much. You'll get more of that later in physiology with Dr. Friedman. Do you guys have him now this trimester? No. That's too bad. Any questions on any of that stuff? Okay. Everyone good with what's on the board? Can I erase it? Okay, so the next thing I have discusses the 6 layers of the cerebellar cortex. Sorry, cerebral cortex, not cerebellar cortex. So there are 6 layers. Just going to number them out. 1, 2, 3, 4, 5, and 6. I can guarantee there will be at least one question on the final on this material. So what's important is to know the names of them to start, besides what number they're associated with. So the first one starts with M, and so does the last one. Like in the cerebellum, the outermost layer was called the molecular layer. And that's largely where a lot of synapses will happen. The other M is for multiform layer. And like the name implies, the multiform layer, you're going to find multiple shapes of cells there. So you'll find pyramidal cells, you'll find granular cells there. Layers 2 through 5, those are going to be mostly one cell type or the other. And they're either going to be granular or pyramidal. The way I remember which one, kind of how to separate them, is that if you want cell phone coverage anymore, you really need 4G, because everything else is outdated. So this 4 is a G. On either side of that is a P, and then there's a G way out here. So you know there's P's and G's in there, not sure where to start. 4G is where you start. So these are going to be granular. And because this is close to the outside, that's considered your external granular layer. And therefore making this the external pyramidal layer. So I think it's AT&T, their cell phone network is 4G LTE. I use the T in that, so 4G LTE. I use the T to remember that this area gets information from the thalamus. It's most of what this area does. Incoming information from the thalamus. The 2 layers deeper to that, those are going to be your projection lamina. Okay, so here in the internal pyramidal layer, that's where you're going to find those giant BET cells. That we talked about when we talked about the corticospinal tracts. These 2 are your big projection layers. Like I said, this was information in largely. And these 2 are going to be your association layers. You very well could see a question that is something along this lines. In Broadman area 2, which cerebellar cortical lamina would you expect to be the thickest? That asks you to think about a number of factors. So we know that Broadman area 2, that's going to be somatosensory. When you're receiving sensory information, that's going to be coming from the thalamus. So therefore, you'd expect Broadman area 4 to be very thick in the somatosensory Broadman areas. You'll find thicker association layers in areas like your frontal lobes, where you're going to be combining lots of stimulus from all over your brain and body to put them together to have those abstract thoughts. That's where you're going to see more cell density in those areas. And Broadman area 4, you're going to see a lot more projection fibers because they're going to be leaving the brain. Any questions on any of that? Okay. Okay, I'm going to stop this real quick.